So I'll be presenting AI security engineer, automatically detecting and fixing vulnerabilities in your code base um, in production code. So far, we have actually found and remediated vulnerabilities in over 100 open source repositories. And these are trending repositories on GitHub, not people don't care about. So, as all of you would know, that security is always an afterthought. Um, it doesn't exist in developers, KPIs. They don't actually run, security scanners regularly. And even if when they're presented with vulnerabilities, there's a knowledge gap. They don't understand the implications and the severity of it. And given their, I mean, I've been a developer, given their, workload pressure, and given these things, there's always a time gap when the vulnerability sort of appears in the code to when it gets fixed. And as a result, whenever there is a breach, there is, it costs millions of dollars. So now I would like you to imagine that there is a tireless AI teammate which is constantly scanning your code for vulnerabilities. And as it finds vulnerabilities, it's doing an intelligent analysis and then creating an automated PR to remediate it, which you can review. That's the world we want to get into. Now, I think you would think that how does it actually work, right? So the architecture looks kind of simple, where there is you can just, hook up your GitHub repository to our tool. We have, scanners for static analysis, dependency checks, also secrets. So we do all the scanning. We find the vulnerabilities. Once we find the vulnerabilities, we use Claude AI to generate the patch which remediates that vulnerability. And once we generate the patch, we do bunch of checks in order to make sure that the patch is robust. It doesn't introduce any more vulnerability. It doesn't have side effects, and it generally follows the guideline of the code your repository. Once all those checks are passed, we create the PR. You would think that okay, it works in some cases, doesn't work in production use cases, but we have had a real world impact on this. We have raised more than 100 PRs in, as I said, trending GitHub repositories, which have more than 5,000 or 10,000 stars. People care about it. And we have got some developer love, as we have mentioned here. And there are some examples of the PRs which have been merged back into the code as well. I think everybody would agree that whenever you're doing any surgical intervention in the code base, you need to have a very robust quality checks and control. So what we do is whenever we actually create a patch, we rescan the code to make sure not just that vulnerability has been remediated, but we are not introducing any more vulnerabilities. We then run your tests, your build suits, your test suite, and to and make sure that it runs. And then we use LLM as a judge to ensure that, because validating that the code doesn't have any side effects is not trivial. So we use an LLM as a judge to ensure that we're not introducing any more side effects into your code. Okay, so this is what it looks like. It's the duality of AI. One AI is, the autofix generator, and the other AI is like a quality judge. So 4.5 creates the patch. Opus 4.1 actually acts as a judge. And the 4. Sonnet, has an exceptional understanding of the code, the context, so on and so forth. And there are sort of retry logic built in. And the Opus, what it does is it sort of makes sure that there is no, side effects and follows the best practices, etc. In this journey, you know, like what are the key technical learnings we have had? First of all, I mean, I think we all know that LLMs are probabilistic machines, right? I mean, they rarely work in one shot, so you have to build a robust retry logic and implement these, retry mechanisms to make sure, you get a significant high success rate. Okay. Second is that whenever you are doing these surgical code changes in repositories, you need to have guardrails in place. By guardrails, I mean you need to make sure that you're not introducing any bugs. Okay? And we follow certain set of best practices for this. Then what we have learned is that in the field of code scanning, um, the benchmarks are missing. Like in cybersecurity, I think like the benchmarks, but I mean like where you have vulnerabilities, you have like a vulnerable code and a patched code. These kind of benchmarks are just missing in this space, so it's hard to sort of and make the community progress. I'll choose this repository. It's from Stripe. It's a payment company we all trust and use. And the purpose is to show that these kind of vulnerabilities exist in all the code we use. It's not in some remote or not sort of. So we'll start the scan here. And while this happens, I'll also show you. I mean, once the scan finish, these kind of results we will get. So there will be 6 vulnerabilities in Stripe Go. I can also show you in Stripe iOS, there are 127 vulnerabilities. So this is, and we trust these code with every day of our transactions. So vulnerabilities exist, right? I mean, there is no debate on that. So what this is doing at the back end is actually, running all the scanners. It's running a SAS scanner for static analysis. It's running a SEA scanner for your, SBOM analysis. It's then running, a secret scan to make sure you have not released or, um, you know, uh, secrets in your code base. Once this will finish, we will see that the vulnerabilities are actually divided into, high, medium, low. Okay. Um, as we can see here, there are 48 high, and so on and so forth. And for each of the vulnerability, we give a autofix option. And once you click autofix, what the tool will do is take, use the vulnerability, call Claude 4.5, and Claude 4.5 will give you a patch to remediate that vulnerability. We'll apply that vulnerability, we'll apply that patch, and then we'll do basic checks, like we'll make sure that the vulnerability has been remediated by running the scan again. We'll also check we have not introduced any more vulnerability, and we'll run build, test, and use LLM as a judge, Opus 4.1, to ensure that our PR quality is good. Okay, this is what the results of the scan look like. So, we'll pick this, try to fix it. And it will take some time because it does a bunch of things. And meanwhile it does that, we can actually look at some of the pull requests we have already created. Okay, so this is for this. I mean, it's kind of a simple change, but um, you know, and these have been sort of merged and as well. So, and this is slightly more involved. But I mean, we have had more involved changes with multiple files as well. But I wanted to pick up the Stripe repository because it is something we all can relate with because we use it on a daily basis, and we know. And I wanted to show that there are vulnerabilities in something we use every day. So we show that we can discover vulnerabilities, we can generate fixes, we can do validation, we can do peer creation and merge. What I want to present to you is that the future of secure development, the security doesn't have to be an afterthought. Security can be your trusted teammate, which is working continuously, monitoring your code as you generate PR, and as it finds vulnerabilities, it actually creates, PRs to fix those vulnerabilities. So, there is no backlog of vulnerabilities you have to live with. That's the kind of world we want to. And there are 3, points I want to highlight here that benchmarks in this space are really missing. Like we don't have security vulnerability benchmarks, so it's hard to make progress as a community. Second is that right now, for the root causing of a vulnerability, we use kind of a simple way. We just pass the vulnerability to Claude. Okay, Claude does the root causing, but we want to have a more intelligent root causing because sometimes scanners gives you, okay, this is the vulnerability, but you have to do a deeper root cause to find the cause could be somewhere else because this is just a. So we want to build more deeper sort of intelligence to do deeper root causing. Um, Thirdly is that developers tend to shrug off to the vulnerability. Even if we show them the vulnerability, they would, even we raise the PR, it's not like, they would sort of accept. So you need to bring some awareness in the developers. And one way to do it is actually show them how it can be exploited. So not just present the vulnerability, but I mean, generating exploit code is kind of a bit hard, but go as close as to that and show it to developers. Okay, this is the vulnerability. This is how it can be exploited in your repository.